Number 3 and number 4 are similar, so I'm only doing number 3. Distance formula, we just got that done. So I'm not going to go through this for very much time. The distance formula is x1 minus x2's quantity squared plus y1 minus y2 quantity squared under a square root. I label everything so I'm less likely to make an error. You can still make errors. I'm proof of that. Notice that I get an 11 minus the minus 5, so that's really 11 plus 5, that's a 16. You have to watch your signs. And then you get square root of 260, which turns out to be 4 times 65 under the radical. So the 4 comes out as a 2, and I get 2 radical 65. So it's pretty straightforward. The only place you can make a mistake is minus sign errors. I'm also going to do number 5 in this shot. It's we've done these before. Here I have an angle B. I'm going to label them. And here's my hypotenuse, the A, that's 24. And my X is the adjacent. So I have everything around B, the angle B, is in purple. And so that's adjacent over hypotenuse, which is cosine. Cosine's adjacent over hypotenuse. So cosine of 40 degrees is adjacent over hypotenuse. I replace the adjacent with x. I replace the hypotenuse with 24. If I cross multiply both sides, so I cross multiply the 24, I get 24 times cosine 40 is equal to x. And so I went on Google and just did cosine 40 degrees. Make sure your calculator's in degrees before you do this, and then multiply by 24, and I get 18.38, this horrible number. But then they ask you to do to 5 decimal places. So 1, 2, 3, 4, 5, this is the last one. And this 6 kicks this 6 up to 7. And you see that that's exactly what they have. And that's what goes in there, at least for my problem. Your problem's different.